Hi everyone, how are you all doing? Who likes to release software? Who gets thrilled by releasing software? I certainly do. And each time I do it, it kind of feels like this, at least in my head anyway. Your tests are all passing, your software is all ready, it's built, ready to go out, and all you need to do is press that big shiny red button. So yeah, that's what you do. Has a nice click to it, a nice mechanical feel to it as well, and then you can just hold your breath and watch it burr. Essentially, at this point, you've triggered the deployment or releasing command, and it's all out of your hands, right? And you can just hold your breath and observe this thing in silence while the dashboard starts showing what the results are going to be. And then you have two options. Option one, keep holding your breath until you go blue in the face. It becomes uncomfortable, and yeah, just wait for a disaster to happen. Or back up your stuff, or if you're already working from home, you don't have to pack up your stuff. You just go to the living room or whatever, but you have done your job and you can enjoy your weekend because obviously it's a Friday, 4 p.m. and you've done your job. I don't know about you, I like be more. And the difference between the two is essentially just the amount and the trust you have in your automation. And it always boils down to automation, regardless of whether you're talking software, as you would at a software developer conference, or agriculture. I'm not talking about agriculture, but I do like to compare it with software development. Imagine a field. You can do everything by yourself or by humans. You can plant, you can weed, you can harvest, do everything by just humans, no automation required. Or you can have some tractors, do things faster with less people and more predictable. Or you can have harvesters, you can have irrigation systems, makes things easier and make things more predictable with some upfront investment, of course. You can also take this several dozen steps further and have this highly high-tech greenhouse setup where you are essentially in control of everything. You're in control of lighting, you're in control of temperature, you're in control of the gases, make sure that the plants are being fed, the nutrients, yeah, everything essentially. And I imagine these giant robot arms do use computer vision to detect essentially which plants are at their ripest in order to pick them up and obviously sell them for maximum profit. And that, my friends, is a great analogy for a really finely tuned CI/CD system. It has everything that you want to do. You've automated everything. You just add source code, magic happens, software is released, your users are happy, product managers are happy, everyone's happy. And the money printer goes brrr. Anyway, or it doesn't. This automation can certainly misbehave in some ways, and while I don't think that we're going to see any of these robot dinosaurs turning against us soon, we certainly can have our kind of greenhouse robots ruin your crops, and your automation that you have for your software projects ruin your customers or your users or your own day, for sure. But fret not, because it's never the machines doing this on your own, it's all your fault. Speaking of people whose fault it is, my name is Zan. I'm a developer advocate at CircleCI, and yeah, I've broken too many deploys to count. Anyway, I do work for CircleCI. We are a leading CI/CD provider. I know a couple of you here are using us, which is awesome. If you're not, please check out our free plan. It's pretty amazing. Anyway, yeah, whatever you're building, we can probably cover it. But this is not to talk about CircleCI. This is a generic or more general purpose CI/CD talk, trying to help you out whatever you're using, however you're using it. I'm going to be focusing most on like cloud-based tools, just because cloud rules everything around us. But before we go into actual kind of nitty-gritty, let's talk about what this whole CI/CD thing even is. So this is the continuous integration, continuous delivery stage of your software development or software delivery lifecycle. And it's everything between you committing some code, pushing a commit to GitHub, for example, and releasing that code to your end users or deploying that into some kind of production staging, some kind of environment. And everything that happens in between can be nicely automated. Like you can have your unit tests, at least. You can have your linters, you can have your security scans happen automatically as part of this kind of continuous integration and delivery pipeline. And of course, you can do the deployments as well. So like whether it's your production environment, whether it's your QA environment, your staging environment, you neatly script those things and set what needs to happen after you push some code into onto a repository. Speaking of scripting things, the way usually is done is you have some kind of configuration file. We use YAML, and it's part of your repository, so it's tied to the same commit. The last thing I want to mention here, the greenhouse thing, is not only it's tied to the same commit, so it's 100% reproducible, you also specify what environments these things happen in. So you specify, okay, I want to run my build job that builds my container image, for example, in this Docker container based on this specific image with this exact version. So it's all tied to the same commit. It's all 100% reproducible. Run this again, and you should get the same results, ideally, hopefully. Anyway, it's complex, but there is a lot of things we can unpack here. So the first and most important one is usually, or what people usually think about whether my CI/CD or CI especially is working for me is, how fast do I get the feedback of my work, whether my work is actually any good? So how fast do I get results from the CI/CD system that my tests are failing or passing? Hopefully they're passing, but you want to know that they're failing, hopefully in a quick, short time. And that's absolutely 100% legit. Because, yeah, that's what it does. You rely on it in order to start reviewing your pull requests or merge requests. You rely on it to, yeah, just kind of continue working on your stuff. So for that, we can do a couple of things. First off, think about where your jobs or workloads are executing. Is it executing in, for example, a machine that has, I don't know, a gig of RAM and like one virtual CPU, or is it executing in a beefy machine that can actually do the things that you want to do? Depending on the nature of your job, think about the executors that you're providing. If it's a cloud-based tool, you can usually just kind of change one line and specify, okay, I want to have more resources. Second one is run things in parallel as much as possible. And that means, obviously, you have all your different jobs defined. So we want to do unit testing, we want to do functional testing, integration testing, security scanning, linting, and obviously all the deployment stuff as well. Make sure to unpack these into multiple jobs and run them all in parallel. And also, if you have multiple tests, like a long-running test suite, which like a lot of functional tests, for example, you can even unpack those into kind of split parallel jobs that run subsets of your entire test suite on parallel jobs. It's doable, it's quite easily doable. We have documentation for it, and every system is obviously different, but think about whether your tests are running fast enough, how you could split them, and do that. Second one is related to when you're building things, how often are you repeating whatever you're doing? So obviously I'm talking about caching here, and caching is nothing else than avoiding repetition by saving something and reusing it later. I'm talking about dependencies, so every time you run npm install or your bundler or whatever you're using, Maven install, for example, you're downloading something from the web. Or you could be hitting a cache and restoring that, saving you some seconds. If your dependencies hasn't changed, you can even reuse them across different pipeline runs, which again saves you a lot of time. You can also cache things that you've already done. So you've built your binaries, you've built your containers, you want to do your testing, security tests, you want to do some functional test on it. So why not just pass that whole thing down the same pipeline and reuse and avoid building it entirely? So yeah, these are kind of things that you can think about when you are speeding up your pipelines or talking about speeding up your pipelines. And obviously, this will benefit your organization as well, because the faster your CI run, the faster you can deploy things, the faster you can ship new features. But obviously, sometimes we hit a roadblock. This is how London looks on a good day. It's pretty red, this map. A couple of months ago, we had a tube strike, and it was all red. I'm actually quite sad I didn't take a photo during that time, but sometimes things happen. Sometimes we break build, as you say, and we want to get that back to a kind of passing state, working state, as soon as possible. What the broken build really means. It means that our default branch, whether it's main, master, or whatever, didn't pass on the CI/CD system, which means whatever we have set up for our deployment cannot go through because somewhere in the chain this is broken. You want to go at it as soon as possible and get that back to green as soon as possible. Couple of things here. First off, know how to log things, like turn whatever it's broken, understand however you're going to be turning on a debug or verbose logging mode and just utilizing this in order to get that log as soon as possible. Make sure you can get those logs out of your CI/CD system, know how to download them, because you probably want to do some grepping on it as well locally if it's something that's nasty to debug. Understand how to get build binaries out as well if you want to poke around the build application or whatever it is locally to see what the CI has done that you don't do locally, for example, if you have some discrepancies there. And just like understand where different bottlenecks are. Usually you have nice dashboards that you can use and look at and see, okay, my test failed in this particular instance. Why is that? Which are the commands? Speaking of which, with Circle CI and some others, there is also the ability to SSH debug. So SSH into a running container or a running VM and then do your debugging on the CI itself, which is super, super valuable. And again, all of these things will help you identify the problem that kind of broke your build and get it fixed as fast as possible. Speaking of as fast as possible, the formulas in the beginning were all a lie. You should be striving for something more like this, so an ambulance, when it comes to CI/CD speed at least, because you're not only here for the speed, you're also here for the payload that you're carrying, so the signal of your application's health and deployability. So that's why you need to kind of strike the balance between go fast, but also carry the signal as intact as possible. And of course, if you see red or blue lights flashing, go fix it as soon as possible. That's it for speed, but there's some other dimensions I want to cover. This is from Monkey Island, by the way. It's an excellent game. They keep locking you in this cage and you keep escaping through a hatch, and they kind of keep adding more advanced doors each time. It's really fun. Anyway, I'm talking about security, of course. How can our pipelines help us ship more secure applications? First off, use them to inject your API keys into your builds so they're not kind of kept in your Git repositories, essentially. I hope that no one's keeping your API keys in your Git repositories. If you are, please leave this talk and go do that immediately, basically. Otherwise, yeah, that's one thing. The other one is set up automated security scanning. There's people from Bridge Crew here in this conference that can probably help you out with this. There's a bunch of tools that automate this. I think Graham mentioned Trivy, which is another tool that lets you kind of scan your containers, which is, again, something you can just add as a step in your or job in your pipeline and do things automatically. So you get that kind of feedback whether your application is secure to a degree as soon as possible. Speaking of injecting API keys, think about when they should actually be injected. So for example, if you have AWS production credentials, only give them to the job that's actually doing the deployment. So really split where they actually get added. There's many ways to do it. In Circle CI, we have this thing called contexts, which allow you to really fine-tune what credentials you pass over to different things and different jobs. The other one is understand whether you need to do some limited access to pipelines based on your roles and permissions model. So let's say your delivery lead is the only person that can authorize deployment into production, so that person can have their own manual step. So only them can go in there and trigger something into production, which is again very, very possible, very, very doable, and it can really bring this whole new secure level of into your pipelines, basically, because you're gonna add this manual review step after everything has passed. So yeah, that's kind of like the security bits and pieces, but obviously there is much more. When we talk about CI/CD, we're talking usually about something like a team responsibility. Whether it's your development team, everyone makes commits. Everyone should be also have some basic understanding of what this thing does and how it's configured and what it actually does. So really have a shared understanding across the team. It's really dangerous if only one person knows how your whole pipeline is maintained and configured, because that person goes on vacation or somewhere else. You lose that knowledge, and it's kind of, you lose the benefit of the ability to quickly debug it if something goes wrong. So yeah, team responsibility. And also, if you have a new team member joining, you can just point them to your CI/CD pipelines and say, hey, this described everything that's happening in there in our project. This is how we do our tests. This is where we do our deployments. Have a look at our configuration. It's just YAML, and maybe you'll have a nice picture of where to start and some new questions based on that, so you don't have to kind of start reading documentation from the get-go. Anyway, I'm talking about only your kind of development team, but there is more teams that can benefit from a CI/CD configuration and CI/CD tool in general, like the whole organization, the whole ecosystem that you have. Not only, yes, your team, but also teams that you can share best practices with, and also people that aren't necessarily in development. For example, your product managers, they probably use tools like Jira, for example, to ticket, to manage their tickets and track bugs, obviously, and obviously make sure that whatever you're building makes sense for the users in the organization. So why not tie that kind of deployment information back to your product managers tools? For example, tag deployments in Jira, which is really, really cool, really possible, and so they can see, yes, this has definitely been released. This bug has been released in this particular version. On the other hand, you have people doing operations, all of your kind of collating all of your information about your releases, etc., in your dashboard. So we've done a release now. Tell us whether something has broken. Basically, you can tag your releases in your kind of operations tools and observability tools and get that information out. Again, think about who else can benefit from your CI/CD tools. And of course, go back to our release in the beginning. Not always things go to plan. Sometimes we wish we hadn't pressed that red button and we wish we could roll back time, but fret not, you actually can, because everything is tied to a commit, as I said in the beginning. So you can just revert the commit and redeploy previously working version. Sometimes it is that simple. Sometimes it's more complex. But anyway, understand that, yes, whatever was committed, whatever was deployed through an automated pipeline can be reverted, and you can get that code out as with the same kind of pipeline, automated pipeline that triggered it in the first place. What I would just argue here or advise here is to have a playbook essentially, so that if something happens at 3 a.m., you need to revert a deployment that you've done at Friday at 4 p.m. Maybe have a playbook, maybe have it practiced a few times with your team so that you know exactly what to do in order to move the resolution of this issue to the next week, hopefully, and you still have some time. So yeah, that's kind of where I was. And to me, ultimately, a good CI/CD pipeline, success with CI/CD means that you are essentially free. You have the freedom to build software on your own terms that work for your team, that work for your organization, and really make everyone happier and better at it, because you have better feedback from your CI/CD tool. You have more happy delivery people who know that, yes, they've had the opportunity to put a stamp on everything before it gets deployed, and you have happier teams because they don't have to do all this toil work that they would have otherwise have to do. So yeah, with this, I will say thank you for your attention. I hope you have a lovely conference, and yeah, feel free to ask me any questions afterwards.